Hello, hello. Happy Cinco de Mayo. We're a day late for May the 4th be with you, but we are here with another episode of the Entity Framework Core Community Stand-Up. My name is Jeremy Likness. I'm here with our guests, Arthur, Shai, and our special guest, Koen. And Arthur is going to kick us off with the state of the unicorn.
Yes, indeed. So it's a little bit different from usual because we've got some updates on the perf numbers that that we showed last time. So essentially what we've done is that we have different sets of hardware here that we run the perf tests on. We have our normal kind of test hardware, which is pretty fast, but isn't the super powerful machines that TechEmpower actually runs their stuff on. But we actually have the exact same hardware here in our perf lab that TechEmpower has. So Shai has taken the results from last time and we've rerun everything on the real TechEmpower hardware. And as is the case with perf, sometimes the numbers change when you change the machines you run on. You change the number of, the amount of memory available and the threads and all that kind of stuff. So we've got some different numbers, but none of this is bad news, despite what Shai tried to trick me over the weekend and not what you want to hear as a manager. Oh, the perf numbers have suddenly changed without telling you which direction.
That worked really well. I'm very proud of that particular.
Anyway, so let's go over what the numbers we have now. I'm going to go over this fairly quickly. Shai's going to write a blog post about it for Preview 4, and we may have it in some conferences as well. But for now, let's look where we are. So this is kind of similar to the graph I've been showing before. So this is requests per second, and the purple line here is EFCore, and the blue line here is Dapper. And then these are just the various different changes we've made. No dates or anything. This isn't a time scale. This is just showing the progress. So our starting point was .NET 5, EFCore 5, and EFCore at that point was 64.2% of the Dapper perf, this being the Dapper perf then. So the first thing Shai did, well, it wasn't really the first thing he did, but the first thing I'm going to talk about here is we did some tuning of the actual use of EFCore in TechEmpower. So, for example, increasing the context pool size to 1024 bumped that up quite considerably. And this is partly because, we're running on really powerful hardware, so we can have a lot of context pooled. But we're going to look at changing the default for that as well. Making a property required, you might not think that this would have a significant perf impact, but it stops us having to do a null check for it when we read out of the database, and is DB null essentially. And so actually you got almost 2% just from making one property required. And then Shai did some tuning of MPG SQL. It's pretty complicated, multiplexing and connection pool size stuff. I mean, not complicated changes, but these are, it's interesting to see the interactions between these parameters. Like I say, Shai's going to write a blog post, so he'll cover some of this stuff, right?
Yeah, I'd just like to point out that that last part, by the way, was actually proposed by Dino Flores, who is one of the NPG SQL contributors. I'd really like to give a shout out. This has been a really, really cool change and spurned some other, looking into other directions. So that's great. And another guy who also helped, who is part of NPG SQL, Nikita Kazmin, who also is responsible for one of these things. It's really great to see people interested from outside in the community, and it's awesome.
Yes, Shai, thanks for that. I meant to put that on the slide, and I guess I forgot while I was doing it this morning. Okay, so then we also now, so this is all just changes .NET 5. It's not really EFCore 5, but it's essentially, this is before we've changed to .NET 6, right? So we changed to .NET 6, and as people should be aware now, .NET 6 is much faster than .NET 5, as .NET 5 was from 3 and so on. We're constantly working across the stack. So we got almost 10% on EFCore just from switching to .NET 6, and almost 15% from Dapper just from switching. That's not changing any of the code there. So that's pretty cool. Of course, that moves the bar for EF a little bit, but that's okay. So the rest of these changes are kind of what we've talked about before and what Shai will cover in his blog post in more detail, but these are the various product changes to EFCore. There's an issue here. We'll put it in the show links. That you can look at these changes in detail and look at the pull requests and everything. But basically, we've got about 31.8% EF. This is just making EFCore 6 faster than EFCore 5. So at the end of all this, it means that a total EFCore is 70% faster than it was on. So EFCore 6 on .NET Core 6 or .NET 6 is 70% faster than EFCore 5 on .NET 5. And Dapper is 14% faster, but there's a lot of discussion going on in the Dapper community right now about various things that they can do to move Dapper forward. So, hopefully Dapper is going to increase more here as well. At the moment, though, we're at 95.7% of the Dapper performance. We had a goal of reaching 100%. I'm happy with this, but Shai's still working on stuff, so who knows where we'll get to. So, yeah, definitely look for the blog post on the .NET blog. It'll be the preview for blog post. We're going to kind of focus on the perf changes in that, tell a little story there. There'll be a lot more details, and I'm putting all the pressure on Shai to make this an amazing post now. So,
yeah, feeling the pressure.
So that's. Go ahead, Shai.
I'll say just one very small thing. So EFCore itself is not per se 70% faster, because this is including obviously .NET 6, and it's including performance, benchmark improvements. So EFCore is really 30% or 31% faster. But then the cool stuff is that these benchmark improvements, which seem like they don't matter maybe, actually feed into our guidelines and into various things. So the stuff like what Arthur said, we realize that the context pool thing is critical, and we're going to make changes to make sure you guys or anybody who's writing code against EFCore doesn't run into this kind of problem. The same thing with making the property required. This is going to go into our performance guidance. So these things actually do have value, even if they're not actual product changes, which you just switch to EFCore 6 and everything runs faster, but they're still very important. So I do think that we can talk about a 70% improvement in a real way, although keep in mind this is a completely full stack thing. It's not just EFCore.
Absolutely. Okay, so that's perf. That's super exciting stuff. I think we can hand over to Jeremy and Koen now, right?
Sure. If we will drop this screen in really quick, just want to share the show links, and I will paste those into the chat for everyone as well. We've got several links that our guest will take us through. And I just wanted to, this is a little bit of a self-plug, but this first link, multi-tenancy with EFCore and Blazor server apps. The whole nuance with Blazor Server is you have a different type of scope that you use to inject your DB context, and we have a specific recommendation. And we've had several questions on how we can accommodate things like multi-tenancy, where you have to change the connection string, etc., on the fly. Mm-hmm. So this link that you can get to through the show links, and again, we'll put those into the chat, is a link that shows an example of that, both if you have a single database and you're just using like a global filter. There's a link out to another blog post in the community that goes down to row level security. And then there's also if you have multiple databases. So check that out. And then these other links, we'll add the performance link to this. We have the triggers, and that's where our guest Koen comes in. So I'm going to turn it over to you and
perfect.
Let you share what you want to share with us.
All right. Yeah, can you share my screen?
I can, but it looks like it's in inception mode right now.
No longer. That's it.
There we go. Oh.
Perfect.
All right, there we go. Yeah, yes,
Great.
It is. No, it's not. Yes, it is. No, it's not.
All right. Yeah, thanks for having me on. I mean, I'm happy to be here. And I wanted to talk about the triggers for Entity Framework Core. So I guess if you're familiar with database triggers, maybe you've seen something like this before in something like SQL Server. So this allows us to execute some code in response or in reaction to something that's happening to our database. So in this particular example, when we add the user to the database, then we enforce that the created on property is set to the current date. Right,
so
and this.
It's like an event handler, in SQL.
Exactly. And this is actually great because this basically it guarantees me that whenever I insert a new user in the database, I will have this property set for that user, which is, I mean, it's a great guarantee for me. However, this is very database centric. You can plug it in your database, but SQL Server has a syntax for this. I'm pretty sure the SQLite, Shai may be able to tell that, but they must have a syntax for this. I know Cosmos DB has a implementation of triggers, which I think is based on JavaScript. So it's very database centric. And EFCore has, at the moment, no real way to easily integrate with this. You could create a migration and add your triggers in there. But again, you will have to write SQL or whatever language you're using. So what this project is doing is it is not giving you access to these database triggers. It does something similar, and it gives you access to triggers in your DB context. So perhaps to give a small demonstration, what we typically see today is we have something like this. So here we have a user service, and this just adds a user to our system. So
can you maybe just zoom in a little bit more?
Yeah, of course.
If possible. That's perfect.
Perfect. Okay.
Thank you.
So we have a user service here. And in this particular case, we just have a user template, and we construct a user from that. Then we had that enforcement we had before, where we set the creation on property to the current date. So whenever we add a user to our system, we enforce the created on property to be the current date. We then also create a welcome email, right? We send the user email say, welcome to our system. Mm-hmm. We add the email to our database, we add the user to our database, we save that, and then finally we send out the email, right? And this method here has a lot of responsibilities. It has to add the user to the database, has to create the user in the first place, it has to create the email, it has to send out the email, and it has to make sure that the created on property has been set for this user. So a lot of things is going on in this particular method. And wouldn't it be nice if we can just do something like this, where we have triggers that set the created on property, where we may have a trigger that sends out the email or even creates the email. And that is what this project is doing. So if I scroll down a little bit, you can see that I have a trigger over here that's called set created on date. And this trigger is the I before save trigger for users. So this thing runs right before we save a user to the database. And what it does is it sees that, hey, we have a context which contains the user that we're trying to add to the database, as well as the change type. In this case, it's added. And we set the created on property to the current date. And that's it. So we have a very simple trigger. And with this trigger, we can now remove this first requirement over here from this method. And now this method became simpler. Not only you have to create the user, add it to the database, and send the email, which is still a lot of work, but it's less work already. So this is what triggers give you. We have another example here in this blog post where we actually created welcome email. So again, we have an I before save trigger that reacts on users. And when we know that the user is getting added, we will create an email and add it to our DB context. Now note that we do not call SaveChanges here or anything, because this is happening before we save the user. So we can still modify our DB context and add stuff or change stuff. Just like in our example over here, before we save to the database, we still modify this property, which will then still be included in the insert statement that gets sent to the server. So yeah, go ahead.
So in essence, this is really decoupling from your business logic the things that are associated with certain entities. It's almost like an aspect-oriented programming approach where you say, rather than everybody needing to deal with doing created date, let's split that out into a separate thing that we handle decoupled from the rest of the code. And then anybody creating a user doesn't have to worry about doing that because it's now handled by this decoupled part. Is that about right?
Exactly. That's exactly what this is. So I will show you an example in a minute that shows you how this is really useful. I just wanted to show you one more part of this. And this is, so remember in this original method over here where we had the user, we created it, we set it created on property. We now took care of this with a trigger. Then we created the email. We also took care of this with a trigger. But finally, we send out the email. We keep track of the email in the database, but we still have to send it out. And we only do that after we saved our changes to the database, right? Because if this fails, we don't want to send the user an email while not having a record of the user in a database. So this one clearly runs after we saved something to the database. And that's exactly what we're doing over here. So in our last example on this blog post, we have a send email trigger. This is an after save trigger that runs after we save an email. And again, it will check, hey, did we add this email to a database? Yep, then we send it out. And in this case, just as an example, did we modify the email? And indeed, did we modify the message of the email? And if that's the case, then we're going to resend that email with a new message, right? This is just an example of how we can both also react when we modify stuff, and we can compare what we modified. So I have to zoom out a little bit for this. But this is basically saying context.entity.message is not equal to context.unmodified entity.message. So unmodified entity gives me the state of the entity as it was before we saved it to the database. So if we updated our email and we changed the message, then this would have held the old message, and this would have held the new message.
That's pretty nice.
Yeah, so that's it's a very powerful system. And again, you can see that I'm calling our email service, our email send service. Where did this come from? This is just your dependency injection. So this is nothing. This is just what you have registered with your application. So you can interact with your services. You can interact with your DB context that we have over here. So yeah, this is. There are more features. Maybe I can show a demo of how I'm using this, just in a demo application.
I have a
go ahead.
So I see in your example code where you were calling SaveChanges, you were doing asynchronous SaveChanges, but it looks like the triggers are asynchronous. So what's the connection there? So triggers are, because I didn't want to have an interface with two methods on us, like a before save async and a before save. I think that would be redundant. So by default, all triggers are async. So if you call SaveChanges in your DB context, as we do over here, which is the synchronous version of it, or the non-async version, I would say, this will then still invoke those triggers in an async fashion. So your trigger will always be written in an async
fashion.
So
That said, yeah, go ahead.
So typically it's difficult to go from, some would say impossible to go from sync code to async code without the potential of causing a deadlock.
Right.
So
Right. So that is something that the application of the framework itself is taking care of. In this case, you can see that I'm writing my triggers in a synchronous fashion. I'm just returning a task to complete a task at the very end. I noticed that this might be inconvenient. There is an extension that you can use where you can just implement a trigger. And then there are both synchronous and asynchronous versions of before save, after save, and some others that you can implement.
I see. That makes sense.
So right, infrastructure is just simple, just one method, but we have like an extension that lets you use a simpler method if you like that.
Sounds good. And then, so one of the things that, one of the reasons that people often want to use triggers is because they want, for example, the timestamp to be the server timestamp. So I suppose one of the kind of downsides, in a sense, of doing it this way is that you're getting these things generated on the client, which I think has kind of two consequences. One, for like things like timestamps, it can mean that you get the client timestamp rather than the server one. But also that if you have other applications that are not EFCore or not EF based that are accessing the same database, then obviously they won't get those triggers. So I definitely think doing it on the client side in a lot of cases is perfectly fine, and this is totally reasonable and pragmatic way to do it. And if you're doing UTC time, usually the client side time from your server, which you should, is going to be a sufficiently good timestamp to put in your database anyway. But I bring those points up because those are things that kind of often come up as questions from customers when they're doing this kind of stuff.
Yeah, absolutely. Good point. Okay. I saw a question in the chat that asked if we can have this on an interface. So instead of a user, if we could use an interface. I have a demo for that. Maybe I can pull that one up. I think it's over here. Yep, here it is. So this may be helpful. I have a soft delete sample. So I call them a trait in this example. I have a trait that is called iSoft deletable. And this trait has a deleted on property. So now I have, for example, this is a very simple model. So I got a user, and my user is iSoft deletable. I got an order. My order is iSoft deletable, and my order item is iSoft deletable. So all of them have been marked with this trait of iSoft deletable. I then have a very simple trigger, which you go over here. Here we see an example of how I use that trigger extension that I have. So here I just implement a trigger that the triggers on any iSoft deletable. I then check if the entity that gets passed to me is deleted in the context in my before save method. And if that's the case, then I will set the delete done property to UTC now, which I should be doing. This is UTC late. And I'm changing the status of this entry with the application context just to be modified. Right? So what I'm doing is this sort of like instead of trigger, I'm aborting the delete and I'm changing that to modified while I set the deleted on property. So if I have my little sample over here, you can see here I have in DB context. I get my order items, my order and my user. They're all linked together. So my user owns this order and this order item, or this order owns these items. I will then add the user and implicitly with that also the order and the items to the database. I will then check, I can probably show you this if I run this.
He knows how to get on Arthur's good side, puts kittens in his example.
Absolutely.
That's the intent. Demo fill. Not entirely sure what it wants me to do. No.
Interesting.
I may come back. I may come back to this. I don't want to linger on too
Because we're
long.
live. It only happens when you're live.
It only happens. All right. So here is an example where I just delete the order item, and I save that, and I find that okay, one thing has saved, and I can find that my order item has its deleted on property set. So before that it wasn't set, but now it's set. It's configured. It's not null anymore. And if I just query the DB context for the amount of order items, I still have 2 items, right? So we started out with 2 items over here. I did a removal of that item. I saved that. And yet at the end of the day, we still have 2 items because this is where the soft delete thing jumped in and prevented my delete from happening. So
presumably you have the trigger there also. You're probably using a query filter. You probably use a query filter for your queries so that
not in this example.
Okay, not in that example.
Yeah.
So getting the soft deleted entities when you query.
That's I also am, yes. So in this example, I would have to type manually where X would not be deleted, where delete would be null. Delete equals null. Right, this is what I would have to do manually in this particular example. Of course, we can automate this and have a query filter, but this example is just about triggers.
Just doing things manually is more pragmatic anyway. Like, don't over-engineer it. So,
right.
But a query filter would work in this case. In fact, like, I think people sometimes miss the 2 aspects of soft delete, which is you both need to have the query aspect to stop bringing things in, but then you need a mechanism for setting what's deleted and handling that. And this approach is one way where you can still have EF set things to deleted, but then save them as modified. Now you have to be a bit careful with various cascading delete patterns and stuff. They might not work quite right on with this, but basically
I have a demo for that.
Right.
That's what to run. I did implement a way to So I had this issue indeed where I would clear my ChangeTracker. So my DB count, my ChangeTracker would not be aware of any of my entities.
Yeah.
I would then pull my user, which indeed owns the order and also the order items. And if I look at my application DB context, I can see that I have my cascade delete configured to be true.
Ah, right. Yep.
So I then remove this user. Again, this is an empty DB context with just the user in there. Mm-hmm. And I get a 4 back. So there are 4 things that have been affected with the save. Mm-hmm. So this is this is in-memory database. So there's not some SQL magic that's happening.
Yep.
The way I did this is you don't really have to understand this because this is using the ChangeTracker itself. Mm-hmm. But whenever something gets deleted over here, I will get that entry from the ChangeTracker, and I will never find any navigation properties, and I will load those in. Right, that way EFCore can load in those entities. I find the cascade changes that I've made, so the delete, and that will kick off and do a load on these subsequent. In this case, my order, and my order will then load in the order items.
Very nice.
And finally, this one, just to know, this one has a priority, and it's a priority of early. The reason for this is we don't want this soft delete or removal thing to run before that load cascading thing, right? Yep. Otherwise, this will undo the delete, and this will cancel out the cascade loading stuff.
Yeah, I think Arthur was also asking because this is one. I think this is one of our notorious things where people get a lot of questions about this, where people use a query filter and they don't kind of appreciate the whole complexity of what it means to soft delete, and it's done really well here. So you've obviously seen this whole thing through, and it's cool. It's cool to see.
Right. This is not production ready in any way. This is just a sample of how you can use triggers.
But it's thinking of all the right things and all the problems. Yeah.
Can you go back to that code for a second? Sorry.
To this one. Sorry.
Yeah. So if you go down that last code, that last line that we can just see on the bottom of the screen there. So this is a great example of how we have higher level building blocks, lower level building blocks with higher level behaviors. So this is why, okay, normally cascading just happens whenever you can change where it's going to be, immediate or when SaveChanges calls or whatever, but it just happens for you. But if you are taking control of some of these things, we have stuff like the ChangeTracker cascade changes, which says, I've just done some stuff. I know you need to cascade changes now, so go do it. And I think that's that's a great example of how very often in EFCore you can drop down to lower level stuff and still take advantage of these features, even if you're slightly modifying the behavior at the top level. So it's great to see that.
Right.
Yeah, I would just add too, I'm often asked what functionality EFCore provides above and beyond simple object mapping, right? And the ChangeTracker is an example of that. And if you're using EFCore and you're not getting familiar with the ChangeTracker, you should definitely start to do that, because there is a lot of functionality packed into that API.
And we have great docs for it now too. Well, I say they're great. I wrote them. Maybe I shouldn't say they're great, but I can say they're much better than they were before because I wrote the ones before too.
So do we have time for a few questions, or did you want to jump into?
Go ahead, questions.
Okay, so
more, but
the first one is, we'll jump into some more too, but let me pop this one up. So is it available for EFCore 5 and 6?
Yes, so it's available for EFCore 3.1, 5, and 6. There is a caveat though. If you want to use it for EFCore 3.1, you're stuck with the EFCore.Triggered 1 version branch. So right now in this demo, I'm using EFCore 6 preview, great. And for the Triggered project, I'm using version 2.3, beta 2. So this is the 2 branch, but I have an example here that uses EFCore 3.1. And here I'm using 1.4 beta 2. So by this time, 2.3 and 1.4 have already been released, so I can get rid of this. But the 1 version is really aimed at EFCore 3.1. And I think the big one there is that EFCore 5 got the change interception logic.
Yes.
So yeah, I had to support 3.1, so we have this old branch here. But ideally, you can use EFCore 5 or 6, and then you're with the latest and greatest.
Sounds good.
That triggers, no pun intended, that triggers a question from me. Actually, this question has been asked kind of 2 times. So EFCore already comes with various interception events kind of things, right? And there's 2 people who asked, how does this compare to DB command interceptors, which were introduced? And also higher up somewhere, somebody asked, how does this compare to the SaveChanges events, which you also have in EFCore? So EFCore is this bundle of interception points, which is a good thing. It's just good to understand exactly how this compares, right?
You weren't saying they were a good thing when they were impacting perfs, right?
Well, they do have some effects, but as long as we can work around those effects, maybe. Anyway, this is not that session.
I know, sorry.
So this project itself is built, basically the 2 branches built on the command interception logic, right? So with EFCore 5, we got this ability to intercept SaveChanges, and we have 2 ways of doing that. We have events that we can just get from a DB context. So I can even show you that, but I think that's now SaveChange. Oh, this the old version. Let me just over here. I can say this will SaveChanges, and I can plug some of my own code in there. Right, this is great, but it's great for simple things, but it's very minimal. There's no async stuff. If I want to use any of my own services that I have in dependency injection, good luck. It's possible, but you have to figure that one out. And well, basically, you don't have much information here about what happened to whatsoever or what's going to happen. Or in this case, what happens. So there is another method, which is command interception. Maybe I can show you that in the code base itself. It's here. Oh, SaveChanges interception. Sorry. This is released in EFCore 5.
Yeah, that's important. I'll say a word about command.
Go ahead.
Zoom in a bit.
Okay. Yeah. So this interface over here, and if I just go to the implementation of this, or the interface, this allows me to intercept a whole bunch of other methods. So I can do it before we save the changes, do it after we save the changes, and there's also async versions of these. And this is actually what this project is using to enable triggers. Now, I know the question was originally like, what is the difference between using this, using the event, using this, and using triggers? I would say triggers is this on steroids, right? You have the ability to intercept individual. So if I go back to a very basic example, I can intercept changes to entities. I can intercept changes to base. So I could say object here. If I had like a for all trigger, or I could put it in an interface here, as you saw before, like the iSolve deletable that I had before. I can intercept things with that. I can also modify the database in here. So as you saw before, I can now add something to my context over here, and be sure that will be cascaded to other triggers. So other triggers will then also run and do something with the stuff that I did in this trigger. But all of this is you don't have this with the SaveChanges interceptor. You have to do it yourself. And as I said before, you also don't really have nice interaction with your application services in this method.
I think
that's very important.
Yeah, I think we can look at it as kind of another example of lower level building blocks and then how higher level behavior build on top. In this case, EFCore has implemented lower level building blocks, which are intended to be extension points for extension developers and application developers to then build their behaviors into. So yeah, you've got the raw interception points in EFCore, but if you want to build these kind of rich behaviors, then I think this is what you need, something more above that raw building blocks, and I think this is what that's doing.
That's correct.
I'll just add one last note, because there was that question about DB command interception. Since we're going through the whole picture of interception points, command interception or database interception happens at a much lower level, right? So that's like an interception point where you get access to the actual SQL. So it happens much later in the pipeline. EFCore has already gone through all the changes and has rendered them into SQL, and it's about to send your SQL to the database. And at that point, you can go over and do something to that SQL. But that's a radically different thing than what we're seeing here, which happens at a much higher level and much earlier in the SaveChanges pipeline, right?
Yeah.
That's correct.
Right. So I can use this to apply triggers to my Cosmos DB project, my MySQL, without worrying about, okay, now I'm at that DB command level. What does the dialect look like where I'm at, right?
Yep.
There's nothing SQL or Cosmos or whatever in this library. It's all just EFCore. So whatever database provider you stack on top of it, it doesn't matter.
That's great, because I just wrote a CRUD application to showcase kind of what's possible with the Azure Cosmos DB provider. And I have a SaveChanges event that's used to store an audit version of the document. Right. So I'll take a look at applying it this way, see how that refactoring goes.
I think I have that even implemented here. I'm in luck. Let me just see. I think.
Oh, this is great. I can just steal the code.
Right. So in this case, I have another trait that I call them. So I got this I audited trait, right? And I have let's say, where's my models? Sorry. Here. I got my student, for example. My student is iSolve delete and is I audited. So my student is audited. What this means is I have a trigger. It's a very simple trigger that just says I before save trigger. When I get something that is audited, I am just going to use a string builder. I'm just going to do some reflection to get all the properties. I'm going to get everything that's either changed from the last time. So if it's added, everything is new. But if it was updated, then maybe I only changed my first name or my last name or whatever. I'm going to grab those properties. I'm just going to do some manual string building here. Again, this is just demo, so it doesn't really matter. So now I have a string that represents what I changed. And then I'm going to add a new audit record to the database. It has a string. And now I got a track record of exactly what has changed in the student when I saved it. And I do this before we save to the database. So if the save fails, then it doesn't do anything. Like, it's not going to leave some trash behind in the database, because this just gets added to the context, and the context will save it to the database.
Sounds good.
So yeah, I have an example.
So is all this code available on GitHub or somewhere?
Yes, it is. Let's see. So yeah, okay, I already got it here as well. So yeah, you can go to GitHub. It's we'll leave the links here, and you can see some more examples over here, like some different types of triggers, links to the articles, how you can use, how we can discover triggers, like how you can register triggers to the database. And I haven't showed you that, so maybe I should quickly show you that. So yeah, maybe this sample is very rudimentary. If I just run this very quickly, if it works today, yeah, it seems to be good. Never know. So I got this a very simple application here, right? And I can create a book here. Hello, it's called Hello World, and this one will cost
$19.99.
$19.99. All right. I'm gonna add a new book. I'm gonna say this is Hello World Free Edition, and this one costs $0. So now in this particular example, we have a very weird requirement: is that whenever we have a free book, then any customer will get the book automatically. So I'm going to create a customer. I'm going to call john@do.com. His name will be John. They create. So now I got one customer. I got 2 books. I got a purchase. Hey, I got a purchase for that first customer. And this book is the idea, not the amount. So I got 1 book. And if I look at my emails, I can see that I got my welcome email and I got my free book.
Very
right.
cool.
So this is a very basic Amazon competitor. If I look at the source code, so for this, I got the initial implementation, which is for the when I added the customer to the system. So here I add the customer to DB context, and then I set up the sign up date. Then I look at the free books. Then I send it the welcome email. I start to create the purchases for all free books that we have in DB. For each purchase, I'm creating an email. I'm saving that again, and I'm sending out all the emails, right? This is an example of just something that is not testable. This is a beast that can be tamed. So I have a version here implemented with triggers over here. And if you look at the same code for that one, so it's customers create, it's just this. So we just add the customer to a DB context and we save. And that's
Very nice.
it.
Yep.
Right, so this is the power that triggers can give you. It's hard to do when you use SaveChanges interception. So here we get all the triggers that do the logic, like send welcome email, auto purchase free books. And again, each trigger is just, I can multiple triggers running for customers, so I can have as many triggers as I want. And each of them is just focused on doing one task, which is either setting the sign up date or auto purchasing the free books. If you look at auto purchasing free books, I'm not doing anything with emails here because I'm just creating a new customer purchase record. And then if I look at the customer purchase records, I can see that here, when we add one, we create a new email for the customer, right? So each trigger is really isolated to do just that.
I love that too, that pattern of basically modifying the entities so that when you fire save changes, all of those changes are aggregated. And if something fails, then you've got basically the whole set failing.
Exactly.
Yep.
Okay. Other questions? I can go on.
How about this one? Because I always ask this, so I'm interested on the question. Interested
I've
to
got
hear
my
the
answer, but I'm
Now,
not
listen,
asking.
when do you use value task instead of task, basically? Is it Shai? You want to answer?
Sure. I mean, so this question is specifically about a non-generic task. So there's really 2 different answers here, depending on whether the task is generic or not. When the task is non-generic, there's nothing being returned, right? So there's still two schools of thought, but in general, it's quite okay to just return task, because if the method is going to complete synchronously, it can still return the same instance of task every time. Nothing is getting allocated. If the method is going to return asynchronously, then indeed it's going to return a different task instance every time. But the situation where you want to optimize that allocation for a method that returns asynchronously is considered quite extreme in general. So the general guidance is, if you're using a generic thing and it might return synchronously, definitely you have to use a value task, because that's your way of removing that allocation. But if it's a non-generic task, unless you're in a very high perf mode, which this is not really the case, then it's really fine to return task, as you've seen here. So that's all pretty complicated. I said it like this. I think it's not as, it's pretty complicated, but I tried my best.
It sounds like a fun weekend project to build something that has value task, and then look at the generated IL.
What I think is that we need to do like the flow chart for this, because this question comes up like every single time. There should be like a decision chart that says, is it generic? Yes, no. Is it this or that? And just post that once and for all. And
It'd be cool to have a graph that shows like the different perf when you based on the percentage of times you
Yeah.
synchronously versus asynchronously and how that changes.
we should, but there's also different schools of thought. Some people say you never know, so why not just always use value task, like the default in a way to value task everywhere. I don't subscribe to that particular school of thought, but anyway, this is a different session.
You don't think it adds value?
Funny. By the way, the May the 4th be with you. I did not know that one from the very beginning of
Really?
the show. I really have to commend you for that.
What rock have you been living under, Shai?
I'm sorry. I don't know. Maybe it's an American thing. I'm not American. I don't know.
So I wanted to pull up this question: how to use query filter per user roles. The query filter is tied to the lifetime of the context, right? So if your context is scoped to a user, you can have a query filter per user. It also has access to, you can write the query to incorporate the user. So I don't know if anyone else has other thoughts on that, but I think the question is, I signed in under role XYZ, maybe I have a different query filter, and it should be possible to make that decision either based on the DB context being scoped to that user, or just the DB context writing the query based on who the current user is. So.
Yeah, Jeremy is the king of multi-tenant. You basically said it. I mean, it starts and begins, I think, with getting your tenant ID or your user or whatever it is into your context. That's like, there's that question. Once you have that, you can reference that from your query filter. Query filters are designed around that idea as well. And yeah.
And I don't know if we covered this or not, but there's a question on controlling the order of triggers. I know you talked about that a little bit.
Right. So when it comes to the ordering of triggers, I think there are two things to keep in mind. So first of all, here, I haven't showed you this yet. This is how we start the trigger service. So we call add DB context as we would normally do. And we configure a database provider, in this case SQLite. And then we just say use triggers. Now I'm using an extension method here. So if you look at my dependencies, I'm using anti-frame recorder trigger.extensions, which is something that I saw as, okay, this could be useful, but I don't really see it as part of the core product. So this is an extension, but what I could have done is just say trigger options.add trigger, and then I can type as a trigger that I want to add. So in this case, triggers.books.outpurchase books, right? And then if I were to add the second trigger, trigger options.add trigger, that's called users in the customers in this case. Now I can be guaranteed that, let me just change this to a custom trigger. I can be guaranteed that auto purchase free books will run before my send welcome email trigger. Right, that's the guarantee that system gives me. If that's not enough for me, or I don't want to trust on the way we register the triggers, because again, I might be using something like add assembly triggers, in which case, I don't know which one comes first. There is an interface that I can implement, which is called an iTrigger priority. And this requires me to expose an integer priority, which by default is 0. So for each trigger is default to 0. But if I made it -1, then this one will run earlier than what other trigger I use. If I give the 1, then this one will run later, right? And I have a simple interface, common trigger priority dot, and I got 4 or 5 options that you can use, which often helps in describing your code. So that's another way of doing that. There's one more way I would say that is. So right now I have a trigger for customer, but I could also have a trigger for object, right? And object is in this case would be the base type of customer. So the way triggers will run is it will first go for the interfaces. So for example, an iSoft deletable, then for the objects, then for the base types, deep, and finally for the customer, right? So if I have something generic, then that would run first before my trigger, before my customer trigger, unless I had that priority thing configured. And on the GitHub page, in the README on the front page, there is more information about how to order triggers. So if you want to read more, you can get it from there.
Sounds good. Great stuff. So I think we have a little more time to do. Should we look at any more questions, Jeremy?
Yeah, I'll take a quick gander. So I think this one, right here, is just asking basically what happens if there's an issue with the database tied to the triggers.
Right.
And I think I know the answer, but I'll let you address that one.
So yeah, right. So let's just say let's implement a new trigger very quickly. It's called a food trigger, and this is just a trigger. Oh, I don't have the extension package here, but this is a before save trigger. Before save trigger on objects. So this runs on anything, and it's also an after save trigger. So let me just implement these methods. So what's happening now is, of course, before saves happens, I might throw an exception here, in which case it just bubbles up as a normal exception. There's nothing special going on. Or I might hit, or the save might happen, and I might hit it after save class. There's one more case, is when the save failed. So if there's a database exception, and for that we have after save failed trigger. So I can also implement this one. And this one, again, gives me the trigger context. So what did we try to change? So in here, we have the entity, we have the unmodified entity, and we have the change type. So did we try to add, update, remove something, and it will also tell me the exception that happened, so I can play with that if I wanted to.
Very nice.
Yeah.
And then I'm not sure it's relevant to how much data is in the table, how these triggers.
No, so there is, when it comes to saving stuff to the database, but it purely comes to EFCore. So I got a performance test. I think you can run it for yourself if you want to, but it's here in the GitHub repo. You can have a benchmark over here that just has two scenarios. One is just the plain overhead. So what if I just add this library to my code base, but I don't do anything with it? And what if I actually start to embrace triggers, right? To start to replace these functionalities that you saw on servers with trigger calls. What is the overhead of that? If I was to just massively write records to a in-memory database, then the overhead of using triggers is about 10-15%. But again, this is writing to an in-memory database, so I would assume that when you use the actual production-ready database, that the overhead, you wouldn't notice it.
Yeah.
So then you just basically left with whatever your database can do and whatever EF can do.
Yeah. It's worth remembering. I mean, this stuff happens as interception in memory inside your application, everything happening in memory with EFCore's change tracking. And then we're actually sending stuff over a network to a database that has to save them, which is going to be generally far more significant than, all these little things. But the answer, as always with perf, just do your own benchmarks with your own application and see what the impact is. That's actually the only answer to that question, as always.
That's great.
Yeah, and if you're thinking of doing perf, definitely look at benchmark.net.
Yes.
Right.
That is, even someone like
Absolutely.
me can code a performance benchmark using it. So it's a highly useful tool. It takes a lot of the guesswork out, and it's much more accurate than just recording ticks and doing subtraction and calling it a day. So.
The number of times, by the way, we've seen, I mean, I couldn't agree more with what Jeremy just said. On EFCore, the repo, we get a lot of issues where people say, oh, look, there's like this perf problem, and we ask them for the repo, we get a code sample, and they've done a stopwatch, at first and in the end, and there's all those questions. Have you thought about warm-up? For example, have you, how many iterations? Why did you pick that number of iterations? Like, there's so many questions there. How do you know if your benchmark is actually accurate or significant statistically? And benchmark.net just takes that out to a very large extent and without making your life more complicated, as Jeremy said. I disagree. Jeremy is completely can code like very easily, like anything. He doesn't need benchmark.net to make it easy, but still, I also do it with benchmark.net when I need to do anything.
My friend, I don't always run benchmarks.
That's
but when
correct.
I do,
How did I miss that?
benchmark.net.
That's such a missed opportunity there. Shit.
I think what Shai just said about what you're actually testing, is a Tech Empower has made that so much easier. Like now that the industry kind of has this standard idea, Tech Empower, people buy into it, whether it's .NET or Java or Node or whatever it is, and it's defining. This is a scenario. It has to do this. It has to do it in these certain ways. So you can't just write some code that is hard coded to like return exactly what it expects or anything like that. And it's a really great way of having a very kind of defined, well-defined scenario and say, right, and we're going to test Dapper and EF on this scenario. And so, all of those questions around, well, what is the warm-up and is it, those were all answered in the specification of what we're doing. So that's one of the reasons we use Tech Empower to show our stuff, because it's clear like that. Obviously, there's lots of different scenarios and Tech Empower doesn't cover them all, and some of them the perf will be very different, but having these well-defined ones that we can look at is very useful.
Very good. Well, I think we should call that a wrap. That was a very awesome library and demonstration. Thank you for coming on the show. Really appreciate having you. Thank you for watching and participating. Reach out to the team with your questions. We're available live on Twitter. We've got exciting things going on. Look for the blog post from Shai, No Pressure Shai, on the performance improvements. And we will catch you on the next episode. Take care, everyone.
Bye.
Okay, bye-bye.